Okay, in this presentation we're going to look at some important things like, for example, the addition rule in probability. So suppose we have two events, A and B, and so essentially what we might be interested in is that at least one occurring is this is A union B, or A or B. So that's how we might sort of verbalize that U there, union, which is or, A or B. Okay, now that can be written as the probability of A plus the probability of B minus the probability of A intersection B. So this is intersection, or in other words, and. So both of them have to happen together. A and B happen together. Okay, so the reason we subtract it here is, let's say down below this is A, this is B. A union B is everything in the shaded area there. Okay, so it's all of this, all of A plus all of B. Okay, so it's everything enclosed by that blue line. Okay, now there's A intersection B is this area here. Okay, and it's been counted twice. So the point of this minus A intersection B, subtracting that probability, is to stop it getting counted twice, basically. So the simple as that, really. Okay, so that's the addition rule. So essentially, you can come up with little. I'll do some of the sort of little examples later on in the tutorial sheet. So addition rule: two mutually exclusive events. So mutually exclusive events. That's something to look out for. Okay, A and B are mutually exclusive if they cannot occur simultaneously. The presence of one excludes the presence of the other. So necessarily, the probability of A intersection B, or A and B, is equal to 0. So there's no intersection. There's no crossover between A and B. So just to sort of update our for this particular example, that the probability of A union B is probability of A plus the probability of B. Okay, since that since the probability of A intersection B is equal to 0. Okay, now for more than two events, let's say we have A, B, and C. Okay, and we're interested in the probability of at least one occurring. Okay, so this is a little bit more complicated. Okay, so essentially what we have here is we are double counting this area here. We're going to be double counting this area here, or this is what we have to watch out for with regards to double counting, and this area down here we will double count as well. Okay, now you notice in here that the intersection of all three, that's going to be triple counted. Okay, so just be careful about that. So essentially what we do here is just similar to the last case. What we've done is the probability of A, the probability of B, probability of C. Okay, now what we're going to do is this is something very similar. We're going to make sure we don't double count all of these intersection areas. So A intersection B, let's say this is A and this is B. Okay, so we're going to subtract that. Okay, and so to make sure that it is not double counted. Okay, so likewise we're going to subtract A intersection C, so let's say C is over here. Okay, and then B intersection C. Okay, now but you notice actually when we put in the triple intersection, or when we started working this first line here, we have counted this center part right in the middle here. We have counted this area here. I'm just going to shade it in. This area here, we have that counted in 3 times. Okay, but then what we do is we remove it 3 times. So just make sure that it gets put in at the end. So it's got counted 3 times, but got removed 3 times. Okay, so it has to be sort of put back in. So we have that plus probability of A intersection B intersection C. Okay, just to make sure it gets put in at least once. Okay, and as we sort of see here, clearly the situation becomes complicated when we're dealing with more than three events. Okay, it's a little bit hard to sort of visualize that, but there are there's things called membership tables, and they are sort of very good at using that sort of thing, sort of managing that sort of thing. Okay, membership tables. Okay. So, let's go back to our mutually exclusive events. So, it's more than two mutually exclusive events. Straightforward enough. Okay, A union B union C. If they're all mutually exclusive, simply add up all of the probabilities. That is to say that there's no intersection between any of those three events. Okay, all intersections have zero probability. So, since that the events cannot occur simultaneously. Okay. And for k independent events, okay, so we're going to name out our events E1, E2, E3, E4. It should be clear that the probability of at least one occurring is, there we go, just add them all up essentially. Now this is actually sort of sets up something nicely for solving a few problems later on, just remembering this rule here, okay? And how this is a sort of the fundamentals of an important rule we're going to use later on. Where, like, for example, I have a medical diagnosis example coming up. Okay, so now at least one versus none of the events. Okay, so the probability of A union B is the probability of at least one of A or B occurring. Okay, now recall that from earlier that the complement rule, which is a very important rule in probability, allows us to evaluate the probability of a complementary event, the opposite event. Okay, so the complement of at least one is none. So in mathematical notation, what we're doing here is the complement of A union B, the complement of A union B is complement of A intersection the complement of B. Simultaneously not A and not B, okay? So this is an important little rule, okay? So essentially it's not quite intuitive as you think. So we've got the union there and the intersection there, okay? So this is a nice little rule here, okay? So essentially one is the complement of the other, okay? Now this essentially is something you might know in set theory. I'm not doing set theory here, but there is, if you're familiar with set theory, there's a thing called De Morgan's laws. Now they come up in logic and in set theory, okay? And essentially that's what it's a sort of an extension of those set theory laws into probability, okay? And yeah, that's it. Conversely, okay. So let's move on from that. So, just to sort of use that idea, at least the ideas in the previous slide hold for more than two events. Okay, so the complement of the union of all of those events is the intersection of all the complement. Okay, essentially, it just applies to more than one event. Okay, so this is sort of just to sort of set up some stuff we're going to see in examples. Okay. So I think I might call this a video here and just set up on the next one here, just to sort of, I've introduced some sort of important definitions there, so I think I'll just sort of leave the definitions now and go back to some examples.